I know it's a big honor to be able to be one of the very few Zifo speakers. So I'm going to do my best trying to make this fun and informative. So let's take care of the fun part first. So I thought, what if I could make an alternative title to my presentation? So I came up with how the Andromeda strain got it right first. Impact of lab data automation on biologics research. So when Michael Crichton wrote the Andromeda strain in the late 60s, it was actually the first science fiction book that talked about how humanity would deal with the biologics threat. So we read this in the 2020s because of actual current events. And I found that it actually contained a complete blueprint on how lab data automation has to be right. And you don't have to buy the book if you don't want to. I can only encourage you to do so, because the whole blueprint is 3 lines of text. Somebody walks into a lab. Hey, the lab manager says, we can do any test you want in the matter of minutes. Everything? Yes. Everything, every test known to man. Right? And they do this by gently looking into a computer screen. Right? In the book, it's actually done with voice control, right? They were more consequent in the book. But they thought that was probably too far out. But of course, this is a real, it has actually a lot to unpack here, right? So there is the thing about speed, right? So automation is all about speed. We need to get results in a time frame that relates to the decisions that we need to make. Yeah, it's complete, so there's total removal of manual intervention, and it's inobtrusive, right? So I always think the best showcase of a lab data or any automation system is actually a black screen, right? You say you want something done, and it's done, right? So now back to reality and to the less fun part, namely to what we're doing at Zifo. So first I want to say, well, we already talked pretty much about all the problems that we are really trying to solve. And these are 3, right? There is the digital decoupling. That means I want to remove the data silos from the actual actions that I want to do on the data, right? And we heard about different approaches, but fundamentally the problem is, how do I go away from a point-to-point integration to a centralized data that I can use to feed to all the operational systems that need to consume these data? There's the verification of data, right? We need standardized data, we need high quality data, and we need to have this data contain the right metadata. And then there's, of course, the best practices, improved collaboration, right? Germans talk about pH-Wert, others talk it differently. So now how do I basically enable a global organization to operate on top of the same data and the same workflows? And of course, the impact of this is that, of course, something has to happen with your IT infrastructure, right? I like to think of this as a middleware problem. We're going to unpack this more later. But now fundamentally, you need to do something to this data as you push it into the centralized data repository. And then what has Zifo done? Basically, we're building out a practice, right? So we have best practices around consulting, to understand what is a good infrastructure model, how do you deal with change management, what's your data governance implications, what should be your data standardization strategy, right? We heard sometimes fair enough is fair enough. Then we have, of course, services, right? Whatever system you build needs to be implemented, it needs to be maintained, And independently, who you're going to be choosing as a commercial off-the-shelf product, you will need to have an implementation partner, right? And you will have to have somebody who can actually go in the lab and work with an instrument. Yeah. And last but not least, you have technology, right? And I'm proud to announce that Bugs made it after all to our meeting. He arrived 8 o'clock this morning from Chennai, and he is the godfather and technical lead of the team in Chennai that builds out a technology stack that we can use in part or as a whole to either augment what you already have, right? We talked about build versus buy. A lot of organizations going the route of needing to build their own system. We have a lot of expertise in terms of how to interface with certain instruments and so on and so forth, right? So having this as defined as a practice gives us a lot of opportunities to create impact, right? And we have used we have examples of each of these components of the practice working as a standalone or in a conjunction to basically build out a system from scratch. So by itself, lab data automation is really nothing strategic, right? It's just this little piece in a reference architecture that if you have super sharp eyes, Paul already had in the slide this morning, right? And you could say, well, it's just about this part here, right? Take a raw piece of instrument data and push it into this data decoupling layer. But of course, the reality is different, right? You have semantic annotation. You have master and reference data. And you have other data sources. So in a very narrow sense, maybe we could call this here lab data automation, but it actually involves much more than that. So if you just think about this from a metadata point of view, there's what I like to call metadata entanglement. No? If you just ask one thing, no? If I need one critical piece of metadata to keep track and make my instrument data fair, the minimum I need to associate a sample info, a batch record, or an experiment ID to it so that I can associate it with something meaningful, right? If I'm putting in lab automation, and I'm now talking about the physical instruments that are doing experiments on their own, they own the sample ID creation process because they're creating samples at will. If I have CROs, they're going to create the samples. Or in the traditional way, I have my sample management system, and then everything follows. But of course, we need to connect the instruments to either one of these systems and in a bidirectional way if we really want to solve the lab data automation problem. And then, of course, on the systems level view, it's again a mess, right? There's already systems in place, and this idea that you come into an empty space and you can design whatever you want is, of course, not the reality that we live in. So bringing this all back to Earth and also to the Andromeda strain, right? If you're thinking about cell culture development or anything like that, now, if you have read the book, you know that the solution of the problem was that the strain, right, it wasn't a virus or a bacterium, but they called it a strain, could only exist in a very narrow pH window. And of course, having lab data automation, they could simply ask the system, give me a view of the pH of all the experiments you've done, and then, aha. So at least the Andromeda strain didn't go to the large language models and to Gen AI. That should, of course, have caught all of this. But ultimately, the end game is I want to have an analytics dashboard that allows me to monitor my process in real time. Right? On the other hand, I have a bioreactor. So it's an Amber HT here. You have metadata synchronization between the automation and the helper instruments down here. You're going to want to push the discrete measurements into one data silo. You want to have the sample IDs in another, and your historian time series data in a third. And then, of course, in order to operate against or in conjunction with the productivity system, whatever, ELN or LIMS, and your dashboard, you're going to, of course, now operate against the data platform. So this is, in my view, a genuine application of what lab data automation is doing. So, of course, this is a very technical challenge, and I'm going to share some of the things that we have done to solve them. Right? So there's some that are associated to IT problems, but there's also some that are simply associated to company culture, to workflows, to domains. Right? But this little pebble here has to lift up all our data strategy. I can't really talk about this better than we've already heard about in the morning, right? So a lot of these organizations we work with are trying to solve this connecting piece in their data infrastructure. So I already mentioned bugs. Now basically what we did is to align the team along the lines of the services line and the technical line. Started 8 years ago. We have now invested about 150 FTE years to build out the practice. We see the connection to the instruments, which is often the biggest problem, as a services issue, right? Because this is really about being able to work with customers and very proactively build new instrument connectors. And we have done several deployments. We have done different examples. Again, Catch, Bugs, or myself, we can talk you through that. But let's go back to the bigger picture, right? So we have our practice here, but it's not the end of the story, right? You need still a lot of supplemental services to really make lab data automation work. You need to have people on the ground that can work with instruments. In some cases, we rely on agents and specific networking configurations to make this all happen. So we have people who can do that. Now there is consulting services, validation services. If you're plugging in data sciences and visualization, we have, of course, data sciences team. So it's basically, now we're looking at this more as an end-to-end solutioning for a very complex problem. I also wanted to say that just the act of taking an instrument and connecting it to basically being even ready to push this into the cloud, there's a lot that has to happen. Right? There is the connectivity to the instrument, right? There's different interface protocols. It's not that every instrument spits out a nicely defined output file that I can simply scrape from a file location and then I can go on my merry way, right? We have SDKs, we have OPC connections, we have RS-232 connections. And we have OS incompatibilities, right? We had the discussion during lunch where can I just retire all my lab PCs and be happy? That doesn't work, right? So right, we have spent a lot of time building these interface protocols. We also worked a lot on the transport problem, right? Where in an ideal world, you could just take an NGS data set and start the upload, and then whenever it's in the cloud, be happy. But you actually need to think a lot about how do I do guaranteed delivery, right? There is issues with local network connectivity. There is bandwidth limitations. Yeah, you have firewall issues. You have different cloud infrastructures that need to be compatibilized. So again, that's where the team invested a lot of time to build out technologies that can do that. And I think it's one of the real advancements that we bring to this field. Then the data standardization, right? This is really more a question of, well, how do you interpret the data and how do you make them human and machine readable? So we're actually building or using what we call an intermediary JSON that we can then add or feed into an ontology annotator. So that goes back to the other question in the morning, where what about allotrope? Where, I mean, from our perspective, we can use any ontology you want, and we just see that there is not a broad adoption. So basically just to close that loop. And then another loop that we started discussing is the data orchestration part, right? That, of course, data exists in an experimental context. They need to be, they need to have a sequence of events. They belong together. So we built a framework to do based on Camunda that can basically do that. But that can also do things like data validation, right? They can check, do you have duplicates? Are we trying to upload the same file twice? It can be used in the context of CROs to say, well, I'm going to do some sanity checks that this is a correct file. Yeah? So there's a lot of logic that we can put around the data pipeline before we actually send it off to the cloud and for use in posterity. So let's come to the parsers. So this is kind of a snapshot of where we are today, 250 plus. You see some of the application connectors here, LIMS, others. We have bioanalytics, we have chromatography systems, we have CDSs, and so on and so forth. You don't need to take a snapshot of this because we are about to pull a website where you can go in. Huh? It's live? Okay. Well, I'm going to still show it to you from our dev site. Here we go. So basically you can go in and you can basically filter to anything you want, right? So you can come in here and check, well, tell me all the bioreactors, hit apply, and you will have them. Right. Or you could go in and say, well, show me all the Agilent instruments that you have integrated with, and you're going to get a list. So this will be updated live. Now it's kind of, now as we're starting to work with more partners on this, it's kind of our central way of looking at what has been already done. All right, so, and thanks PDG for getting it live. I am very excited about that. All right, obviously we have also done a lot of work in terms of architecture, and PDG explicitly said don't talk about architecture. I just wanted to say that we have it. We have worked on how do you architect something like that. Now, if there's interest, now we can talk about this at length. You have the absolute expert in the room, and if this is anything you need to know about, we can do it. And I just wanted to round this thing up with saying, well, there's also, of course, the receiving end of this, which is the end user. And I kind of put some bullets around the bioprocessing example or the cell culture development example that we already talked about, and just point out and highlight some of the bits and pieces that we have done over the years, right? This doesn't mean that we have done everything at every customer, but we have done work around this in various ways. And now just to talk a little bit about that, now here is a case study where we basically did very much in the spirit of increasing the data visibility. And this was actually just purely implementation services and consulting to basically build two data streams, one from the source systems or the productivity systems, and one from the instruments, so that you have a consolidated view on your data, so that you have basically a dashboard where you have the entire time series data, the discrete measurements, and all associated experiment data combined, right? So there's a lot of work that went into this. There's a lot of technology that's needed to actually make this happen. Scalable cloud architecture, and a lot of these experiences actually went into our tech stack, so that when we do this the next time, we can actually accelerate and build better solutions for you. All right, then just to say that now with this BPMN tool, we can actually build some pretty complex data acquisition pipelines, right? Everything in an HPLC run, from sample preparation, plate preparation, inventory registration, running and routing back of the results. We have even done interfaces to actual standalone software, where we're basically saying, hey, now the data is ready for you to analyze. And then when you're done, you can pick the data back up and basically do a full round trip from the LIMS to the instrument, to the control software, back to the LIMS. Yeah, and with that, thank you very much. Hope this was interesting.
So questions, please, so Max. Okay, right, 2.
Well, I think we should separate how integration to LIMS and ELN. I mean, there's a whole team in Zifo that does that. So now we basically started building up the practice last year in North America. Yeah, so we have now a number of projects that we have run and that we are running. But don't worry, we can take on more work.
How many people in your team?
So in Buck's team, it's about 45. Yeah. In the US, we have myself and the project manager. Now the aim is to offshore as much of the work as possible. So we're really doing the local coordination on site, and then pushing the work to the Chennai team. So the local project manager has the role of basically coordinating the work. Anything that needs to be done in the lab physically is covered by our colleagues in the lab compute world. Right? They already have excellent knowledge on the control systems for the PCs and so on and so forth. So it really doesn't make sense to build out another team there. Right? And then the same, of course, for validation or any things that come after the project, managed services or cloud hosting or whatever else we may need to keep the system alive, right?
And if you add up all of those teams, you end up at about 1,000 people.
Right, it takes a village. That's the message. Yeah.
It does. Another question here.
Yeah, hey, thank you for the presentation. Really interesting.
welcome.
And I was curious to see your opinion on this. There's been also some trend in the industry that people are going hybrid cloud, meaning that they still do on-prem, let's say, storing images, but then they do the compute in the cloud. Do you see an impact of that from a lab automation perspective? And can Zifo actually support both?
Well, I would actually encourage that, right? I mean, in the distant past, you see that I'm a little bit gray, but I have actually done physical lab automation, and we have done high throughput imaging, right? And I don't know if you necessarily want to push giant data into the cloud. So I think the hybrid cloud approach is the right thing. And it's also, I think, a reason why it makes sense to work with a services company on that, because we have no ambitions in building your cloud data platform, right? So we look at this more from a connector point of view, right? So we can connect into different storage locations, whether that is a cloud or an on-prem location, is really more than a part of the services configuration work that we would do as part of the project.
Thank you.
my point was a question related to raw data archiving, because we, in the chemical industry, we need, and scientists need to come back to experiments they done 5 years ago, 2 months ago, 10 years ago, and
Yep.
they ask us to store everything in a raw data format. And at the end, this is a huge amount of data, as we discussed
Correct.
before. And the target is not the ELN and the LIMS. The target is to how to catch data, keep data for a long period of time, and propose to the researcher to do post-processing on all data, meaning that they want everything. We had an incident, for instance, in a specific site, and they lose some data located on a laboratory PC, for instance, and there were mistakes. And at the end, they lose hundreds of hours of experiment because they lose the raw material they test before. And as the raw material disappear, they want to keep the data that were catch at that time. And
that's, of course, at the core of data verification.
Indeed.
Right? And so we think the best practice is to store the raw data in a cloud environment or on-prem, if you so wish, RAID system or whatever you want, and then fingerprint them and then connect a link to the raw data to your ELN experiment or LIMS entry so that you can retrieve the data if needed, but to not overload your ELN. And I think in the larger picture, the ELN is also a data silo. So the spirit of digital decoupling is really to only push the quintessential information into an ELN template and keep the raw data and potentially also even the process data, the standardized data somewhere, right? Because depending where you sit, you may want to also think about data retention policies. And we have actually done work where we can basically offload data to longer term storage facility, Speak Glacier or any similar.
Good. Okay. Thank you,
Right.
Max. Thank you again. Thanks, my friend.